So my name's Rob. I'm going to be talking about serverless payments in JavaScript at Mate.com and Veygo. So they're two companies I've worked with recently. I'm going to kind of build up to that. So initially I'm going to talk about AWS Lambdas and how you can use Lambda Layers to create your own microservices. So I work for Theodo, which is a kind of software consultancy firm, working with clients to try and solve their problems, solve their business problems. In JavaScript, that might mean building React web apps, React native apps, or in more recent times, Node.js Lambdas. So I'm going to show a few links throughout the slides, links to repos, articles. But the slides can be found at slides.com/RobCronin if you want to see the links at the end. So a quick summary of what I'm going to be talking about. I'll give a quick intro into Lambdas and serverless and how we deploy them, and give a quick demo just to show how quick and easy it is to deploy. The local development experience is quite nice. And then I'm going to talk about a few use cases we've had on Theodo projects to show how we've used Lambdas to solve different issues. That's going to build into Lambda Layers, which is something that was released by AWS kind of November 2018. So that gives you three different ways of using the layers. I'm going to talk about one of them in particular. And then I'm going to build into the payment services and then finish up maybe talking about the pros and cons of using Lambdas. So first of all, just if you're not familiar, if you want a quick refresher, on AWS, Lambda allows you to not think about servers and only pay for the compute time that you use. So you don't have a server running 24 hours, you just pay for the code that you want to use when the customer calls it. AWS deals with all the scaling issues, you don't have to worry about load balancers. It creates new instances of your function as and when you need them. And compared to servers, it's quite cheap. So if you look at the pricing, even after the first 12 months, you can still use the free tier. You get 1 million requests for free, you get a certain amount of memory for free. Compared to servers, it's a lot cheaper. So basically the benefits of it, it's ready to run, launches new copies as you need it. And something I'll talk about at the end is kind of how you get logging kind of for free. You can just do console log in JavaScript and it streams them to a log stream for you. So the way we have used to deploy them is using the serverless framework. So this is a command line interface allowing you to, well, this is an NPM library, but allows you to build, deploy, update, and delete your Lambdas from the command line, or even on your CI. So if you're using Circle, Travis, Jenkins, it can just deploy in one command. So serverless deploy, serverless remove, etc. It gives you the option to deploy straight away with a minimal configuration, or go to the extent of tweaking everything in the AWS console if you want to, which is nice because you don't have to worry about developers changing things in the console. It's all in the code. So quickly, I'm going to show a quick deployment of a Hello World Lambda. So serverless, the library gives you a few templates. So for Node 8, it gives you a template for that. But then there's also some GitHub repos that give a nice kind of more extended template that give you a few things out of the box. I was using one for a while that gave you Webpack config, so you can use the more modern syntax. And then I just kind of built one on top of that to add a few things that I was always adding, giving it Babel 7 support, adding like a linter and prettier. But basically you can use any of the templates or other people's GitHub repos. So this SLS is short for serverless. You can install with a URL that points to any GitHub repo, or you can give it a template name that serverless give you. So quickly we can deploy this command. If we go to terminal, we can run this. And basically what it does is a git clone. It pulls the GitHub repo and just creates your folder for you. If we go to Hello World, we can use Yarn to install our dependencies. From the template, there's actually only 2 non-dev dependencies, which are to do with Babel to allow you to run, to allow you to use the more modern syntax. And after that, I can deploy straight away. I can run yarn deploy, which is an alias for serverless deploy. And that's all that's needed to deploy this template, which is a Hello World. The first deploy takes about 90 seconds, and all the subsequent deploys take about 30 seconds after that. So while it's running, I'm just going to quickly talk about what's happening. So first of all, I've had to link it to an AWS account, of course. It's not just going to deploy anywhere. So if you're used to AWS, you can get these access keys and secret access keys. If you're just playing around with it, you can use your root account, and then obviously when you go into production, you can create an IAM role, which again, if you're not used to AWS, it's just a way of creating a user, giving it specific permissions. This allows you to this is kind of a minimal setup. I just put it there for the sake of filling the screen, but it's the minimum setup that will get you a Hello World deployment. So that goes at the home directory of your system, Or if you're using, say, Circle, you can add the credentials directly in the settings there. So that's pointing to my AWS account. So when I run serverless deploy, it'll pick up those credentials and deploy to that account. The actual configuration, so making it actually deploy in the way that I want it to do, is use serverless.yml. So this is your config file. This is a very minimal setup that will get us the hello world one. At the bottom, I have a link to the serverless docs where you can tweak basically all the settings in the AWS console that you need to. So running through this, I'm saying the service name is hello world. I'm using a plugin to allow me to use Webpack, and I've specified a Webpack config, which came from the template. In the provider, you can give it a name of a provider. I've mostly always used AWS, but it gives support for all the other providers. I'm using the Node 8 runtime, and this is my development stage, but you can give it a staging or production. And then you can specify a region. So the actual Lambdas go under the functions. So you can declare as many functions as you want here. I'm just declaring one for hello. The handler is where the code lives, which is in a handler file, hello function. And then the event is what actually triggers the Lambda. So in this case, I want it to be able to trigger it from an HTTP request, GET request to /hello. So that's the minimal configuration. If we go back to the terminal, it should have deployed. So you can see here it took about 85 seconds for the initial deploy. If we run through what that's done for us, it's bundled my code with Webpack. It's then created a stack on AWS, which is an AWS service. It's called CloudFormation. Serverless creates the CloudFormation file and uploads it to S3. And CloudFormation is an infrastructure as a service. You can declare what you want in a text file. For the sake of a Lambda, it creates 5 things for you. It creates the actual Lambda, the S3 bucket to store the code, an IAM role to give permissions to your Lambda. My mic just go? Is it still good? Can you guys still hear me? I'm not sure what's gone. I can speak loud, but I don't know if people can hear me at the back. So yeah, the CloudFormation file is going to create the Lambda for you. It's going to create an S3 bucket. It's going to create the IAM role to declare the permissions for the Lambda. It's going to create a logging service for you. And it's also going to create, it's going to set up the API gateway for you, which is another service in AWS which deals with your API requests. So it will provision your Lambda when and as it's needed, create new instances of it if you're getting concurrent requests. Can everyone still hear me, or am I not shouting loud enough? Cool. So after it's updated here, it just gives you some information at the end, including the actual endpoint, which will allow us to hit the new Lambda that we've deployed. So if I go to that endpoint and zoom in a bit, it just returns a simple object, which is the default that comes with serverless, saying your function executed successfully. If we want to see what the actual code is that created this, if we go into the handler file, it's a very simple function, just returns an object with a status code and a body. If we wanted to then edit that, so if we were tweaking this to do something else, so just a simple hello string, we could then deploy that as well, and it would take about 30 seconds. But obviously you want to be able to check that something works locally before you actually deploy it. So there's another package called Serverless Offline, which simulates what the API gateway does for you, which is a very handy package. If you have a number of Lambdas running, you can have them all run, and your actual app will point to them and use your local versions if you need them. So what this does is actually creates a server for you, which kind of goes against serverless, but it works locally. So if we go into Hello World, if I run yarn start, it's going to pick up my serverless offline start and run my Lambda on a localhost 3000. So if I go to hit, if I use Postman to hit this guy, if I go to localhost 3000, it's going to give me a 404 because I've only specified I can zoom in a bit. I've only specified the hello path. So this localhost 3000 doesn't exist. If I go to localhost 3000/hello, I get my new message, which is just hello. So the local development experience is really nice. You can tweak things as you go and then deploy them when you're happy it's going to work. So that's the hello world. I want to look at use cases for actual times we found these useful working with different clients at Theodo. So this is 5 ones I'm going to run through and end on the payment services. So I'll run some now, but I'll just go one by one. So my first time looking at Lambdas was when we were building GitHub pull request status checks. So I was working at a client that used the pull request names to generate release notes and spread them amongst the business. As I'm sure you're aware, many developers don't really make nice pull request titles at times. So we had to enforce the rule. So this is checks you've probably all seen. The test CI would be like Circle CI, but then we've added 2 extra checks on our repo. So a name checker, which in this case has failed because it's not of the right format, and a time of day check, which is just kind of like a sanity check to make sure you don't accidentally merge to the production branch out of hours. So if we see that in action, I have a repo here that's got this setup running. Maybe zoom in a bit. You can see the check is failing here because it's not of the right format. It needs a ticket number. So this would be like a team name, a ticket number, and a user story. In my case, I'm missing a ticket number. And if I add a ticket number, it's not going to check it's a real ticket number, but it's going to check that it exists. You should see this turn to green if it's working, which probably won't on a live demo. Refresh, you can see now it's gone to green because it's of the right format. So the way this worked, if you're an admin of your repo, you can go into the settings tab and go to webhooks. And you can see here I've created a webhook for pull request events. So every time you create a pull request, edit a pull request, add more commits to it, it will create a pull request event and send it to a webhook of your choosing. So I've specified it to hit a Lambda that I've previously deployed. And every time something happens, it will send that event to the Lambda. The Lambda will run some checks, and then it will use the GitHub API to actually update the status check on the pull request. So we use that to check that the name was right, and we also use it to check if the time of day was right. So that was one use case, written an article on it and a repo that you can use if you're interested on using it on your own project. Again, the links are available on slides.com/Rob Cronin. The other one we did was for using cron jobs. So the first Lambda we deployed was activated using a HTTP request. You can also schedule them to run at certain times of day. So here, to compare them, this is the hello function we deployed before. It's triggered on this event, which is a get request to /hello. The one on the bottom we're triggering on a schedule. So it's using this cron syntax, which if you're not familiar is 0 minutes past the 3rd hour every day of the month, every month, Monday to Friday, every year. So basically it's going to trigger at 3 a.m. every day, which is when you typically expect your servers not to have a large load. And we use it to run analytics. So you gave the Lambda permission to run whatever you want, generate some reports. There's of course other ways of doing this. Lambdas are just kind of a cool way of doing it. We also use the cron jobs for the GitHub status checks. So if you just ran the pull request name when you created the pull request, if you created at 3 p.m., it would go green for time of day and always be green. So instead we scheduled at 4 o'clock to go through every pull request that's currently open and make them all status pending. And again at 8 a.m. in the morning to make them green. So the third one, this was kind of an interesting case where, because we were using Lambdas, we just kind of thought of using Lambda to solve an interesting problem. We had a Django backend, and we had a third party that would send us requests that we wanted to deal with. And when the third party sent us the requests, they were coming in chunks, so they were coming bit by bit. And this meant that there wasn't a content length in the request, which our backend rejected with a 411. We asked the third party if they could tweak that, but they weren't able to just for us. And it wouldn't be good practice if we allowed infinite requests to our server. So what we did to just try it out was we deployed a simple Lambda, which basically looked like this with a little bit of authentication added on. It took in the event and just forwarded the request to, in this case, our backend with the exact same event.body. Very simple Lambda, but the reason it worked was because when you send a request to a Lambda, it goes through the API gateway, which actually buffered our request and added a content length, which then allowed our backend to accept it, which was kind of a bit lucky, but it was kind of an interesting way to solve the problem. So to show you how we might do that, so for these 3 examples, I pulled the same template that I did for Hello World, and I'm just going to show you what I've changed. So the handler function is what I just showed you in the slide with a return body. And in the serverless.yml, all I've changed is the function name, and now it's a post request instead of a get request. And if I was to run that again locally, so I'll kill the hello world, and go to middleman, and start up that server, On the left-hand side, I can simulate a backend server. So on the left-hand side, I'm simulating the Django backend that would normally reject this request. Here on the right, I'm simulating the Lambda, and then I can simulate what the third party would do. So again, using Postman, I can hit my middleman request with a body of, say, via Lambda. I send that request, I get a success, and you see here that my backend has received it, and the Lambda has forwarded on. So then, a quick and easy example that we used Lambdas to solve the problem. So another one that's actually quite useful for all third parties, not just for mail clients. So often when you're dealing with third parties, if you, for example, only have a front-end only app, or you don't have access to the back-end, or the back-end team is busy, and you want to be able to send authenticated requests to third parties, you don't expose your API keys on the front end, of course. So for example, if you had a mail client, if you expose the API key, someone could then send infinite mails on your behalf. If you put it on the back end or on a Lambda, you can specify that it only sends certain templates, which is a little bit better. So here we're saying we use AWS's SSM, which is the parameter store, to store secrets. So here I've stored a secret API key, and I'm going to access that from the Lambda. So there's this code here. We don't have to worry about too much about this code. You can find it online. It uses AWS SDK and allows you to access various SSM parameters. So you give it an array of the parameters you want, and it will return an array of the secrets. But this is something we found ourselves doing quite a lot on different Lambdas. So it's the sort of code that you'd want to put into the new feature they've released, which is Lambda Layers, which allows you to share code across your Lambdas. Instead of deploying your Lambdas individually, you can deploy a layer and then use those layers on each of your Lambdas. So in the serverless.yml, instead of declaring functions, we're declaring layers here and giving a path to where the code lies. So when you deploy that, we get a similar stream of messages, again uploading the zip of the file, doing the cloud formation. Instead of giving an endpoint back, it gives an Amazon resource name, an ARN here, which you can use on any of your Lambdas. And when you do that, at runtime of your Lambda, it puts the layer code in the /opt of your directory, and then you can import the code directly from there and use them. So if I show you an example of this, so the third-party example, first I'll show you the difference in the serverless.yml. So here in the provider, on top of AWS and the 4 things we had before, I've given my Lambda permission. Because obviously you don't want any Lambdas to be able to access your SSM store. So this is giving it a get permission on your SSM parameters, and I've specified explicitly it can only get the secret API key. So the Lambdas are quite nice in fine-graining the permissions and making sure that it's secure. Again, I've changed the handler to be third-party, and at the bottom here I've added a layer, which is referencing the ARN that I was returned before, which is the access SSM. So now there's a little script I have that runs that sets up the Webpack config to allow you to access that code when you're running locally. But I've got something in a few minutes to show you how that works. So if we look at the actual code, I've imported the get SSM from the /opt. So when this runs when the actual Lambda runs, it will have access to all that code in that directory. And then I can use it straight out of the box in my Lambda. So here I await the get SSM of my secret API key. In reality, I would then use that key to contact my third party. Here I'm just returning it in my body to show that it works. So I previously deployed this Lambda. We can look at it here. So it's just going to return a body with the very secret API key here. So that's showing how, so this is a very small example. The SSM code is not that long, but you can probably find use cases where you might want to use layers across all your Lambdas. This is the repo I mentioned where you can set this up for yourself. So I've got 2 repos with the actual Lambda code and the layer code allow you to deploy a layer and then use it on your Lambda. There is 3 cases that AWS mentioned could be used when you use Lambda layers. The first one I've just mentioned, where you can reuse your code across the Lambdas. The second one's quite similar for library dependencies. So in the case of JavaScript, this could be your node modules could be living on a layer. And every time you deploy it, you don't actually have to deploy your node modules as well, which makes the deployment a little bit quicker. And then the third one is for custom runtimes. So out of the box, AWS supports JavaScript, Python, Java, a few other ones. But there's other languages that you might want to write a layer in. For example, in PHP. So my colleague Ben at Theodo wrote an article when he had to write some PHP lambdas. So the one at the bottom here, he wrote a custom runtime to allow you to run PHP on your lambdas, which is kind of cool. And then the top one is how I integrated the layers into the lambdas. So on to the main one, the payment services. So over the last year or so, I've worked with both these clients with Theodo. So Made.com, an online furniture store, you might have seen their ads on the tube. And Veygo, an insurance company, part of Admiral Insurance, to provide short-term insurance to young drivers. So in both cases on these projects, I found myself needing, or the team found themselves needing, to create a payment Lambda. So for Made.com, we were building a React Native app with them, and we were integrating Apple Pay with it. And due to some constraints, we couldn't use the back-end version of their payment system, so we had to create it ourselves. So we use Stripe as the payment service, which you might have heard of before. And on the front end with the app, using Apple Pay, we could generate a Stripe token. And we just deployed a simple Lambda that would take the Stripe token, take the payment amount, and take a reference to the order. The Lambda would receive that. It could do some checks with the back end to see that the order was legit, see that the amount was right, and then actually make the payment with Stripe and return to the back end that the order was the charge was either successful or not. So it's quite simple code, and it kind of eliminated our dependency on having to rely on the back end. For Veygo, it's slightly different. So we had access, we were writing the back end code as well, but we were building a number of different products. So at the time I was there, we had 3 different products. They all had to deal with payment at some point in their flow. And we didn't want to rewrite the same payment code every time. So whether that was Stripe or PayPal, which we were supporting, we wanted to be able to generify it and refactor it into a microservice. So again, we wrote a Lambda, which you could give it a Stripe token or specify the payment method, do your own checks on the back end, but then have the Lambda deal with everything else. So to show you how quickly you can actually set up a payment service in a Lambda, this is about 40 lines of code, which would give you a very simple version that would work. So we use the Stripe library. Again, I'm using my layer because I'm going to have to access some secrets from SSM. This is a bit small. Maybe I'll go to the... Can you guys see it at the back? Or like? Okay. So the actual event, it gets the Stripe secret from SSM and then configures the Stripe library using the secret. Parses the body that it's received. And then here I mentioned before, you can just use console log and it will give you logging out of the box. If you're using Python, you can just use print. Here I'm saying log that you're about to charge for the amount, and then try catch the request. So create the charge using the amount you've sent and using the source token you've generated. We can catch the error, log the error, return an error. It's all straightforward code. And then eventually log a success and return it. So that's roughly 40 lines of code that gives you a very simple payment service out of the box. To look at that here, so again, the handler code you just saw, package.json, I've added Stripe as a dependency. Serverless.yml, again, I have given it the permissions, in this case just for the Stripe test key. And at the bottom, I've given it the layer again, and it's a post to payment. So again, I've deployed these. So if we give it a body, so I've set up a Stripe test Stripe account. And with the test account, you can use token_visa, which will always be successful. I've given it a source and the amount. And if we send it to this Lambda, we should see it should make the request to Stripe and give me the charge ID from Stripe. If I was to do a failure, which is a token_charge decline, we should see the error message that Stripe gave us, which was your card was declined. So to show you how the logging comes out of the box, from the console, we can go to Lambda. We can find our Lambda, which here is Stripe example. And this is the dashboard, which I haven't had to touch using serverless. Anything I would want to change here, I could theoretically do with the serverless.yml. So you can see it's got my code. It's got a few tweaks you can do in terms of the amount of memory it's allowed to use, concurrent requests, etc. You can see the other things it's set up for me. It's set up the API gateway so that I can hit /payment. It's set up logging, which we'll look at now. It's allowed to create logs and put to them. It's given a permission to access my Stripe test key. It's said to use the layer, the Access SSM layer. And then we can actually look at the logs. So if you go to the monitoring tab, it gives you some very simple metrics. etc., how many times it's been invoked, and then we can actually view the logs in CloudWatch. So this is kind of, the logs are not the nicest out of the box, but they're there for you. So if we look here, we can see the requests I made over the last few minutes with the logs here. I might zoom in. So it gives a unique ID to the request. It was about to charge, and the first one I did was successful. It gives you some billing information about it. So you can see that I only used this amount of memory when I'm actually billed for this amount, so you can tweak it as you need to make sure you're not overbilled. The second one I got declined, so you can see the arrows here. So the other thing you may have noticed, and you probably heard about Lambdas, is to do with the cold start time. So the first one I made, you can see, you might not be able to see, it took about 2 seconds. The second one I made took just under 1 second. So the first request you make to a Lambda is going to be a bit slower because the API gateway provisions your Lambda and sets it up. Every request after that will then be able to use the same instance if it's still alive, and it'll be a bit quicker. So some articles I read, they think they will last about 40 minutes. If you use a lot of memory, it will get shut down a lot quicker. AWS deals with that sort of thing. So I haven't hit this Lambda in a while, but if you're in production, you'd expect it to be hit quite often. And AWS said only about 0.2% of requests actually experience a cold start. That might be because people are being smart and scheduling requests to keep their Lambdas warm. But the other thing, if I send 10 concurrent requests to my Lambda, it would have to instantiate 10 instances of it. So even if you're keeping the Lambda warm, if you experience a busy period, it's going to, like 50% of those might actually still experience a cold start. So that's something you have to think about. In the case of payment service, maybe an extra second is not so bad, but if you're using it for other things, you might have to think about that. So just a quick overview of the pros and cons of using them. The deployment's really quick. The dev experience is really nice. You can deploy in 30 to 60 seconds after the first deploy. The initial one takes about 90, but that's still quick if you want to kind of do a proof of concept and see if something works. You can log out of the box with console log. It's a lot cheaper compared to the servers. I didn't go too much into the pricing, but you can get over, if you go over the 1 million requests, I think it's about $7 to get another 1 million, which is not too bad if you're getting 1 million requests to your payment service. You can share codes with layers. It deals with all the scaling for you. And then the two negatives I mentioned, the logging is not that nice. You might set up your own logging anyway, or you might pull the logs from CloudWatch and deal with it the way you want. And then, as I mentioned, the cold start time. So that's basically it. As I mentioned, the slides are available if you want to see any of the links. The repos are there, and the 3 articles I mentioned you can find. So thanks very much for listening, and if you have any questions.